You know you need to learn data structures and algorithms to pass your technical interviews. But when you look at the sheer volume of concepts, it is incredibly easy to freeze up, unsure of where to even start. By the end of this video, you will have a complete step-by-step 12-week study schedule. It outlines exactly what to learn week by week to prepare for those interviews. To get started, you only need 3 things: a basic understanding of computer operations, a Python coding environment, and the willingness to block out 1 to 2 hours a day. Following this specific chronological sequence is the surest way to avoid tutorial hell. Sticking to the plan will save you hundreds of hours of directionless studying. Step 1. Weeks 1 and 2 are dedicated strictly to mastering core Python fundamentals. You need to be comfortable here before you attempt any complex algorithms. As you can see in this checklist, these are the Python components that must become second nature. You need to write variables, loops, lists, dictionaries, and list comprehensions without looking up the syntax. Once you have those basics down, week 2 introduces a critical habit. Whenever you write a piece of code, you must interrogate it by asking 2 questions. How much time does it take to run, and how much memory does it use? To measure this time and space complexity, we use an industry standard called Big O notation. This graph charts the number of operations against the number of elements processed. That flat green line represents O of 1, or constant time, meaning the operation takes the same amount of time no matter how large the data gets. Next, the diagonal yellow line shows O of n, or linear time, where operations increase steadily with the data. But look at the sharply upward curving red line. This represents O of n squared, or quadratic time. Here, operations multiply rapidly, slowing your program down significantly. Choosing an algorithm with constant or linear efficiency instead of one with quadratic time is often the exact difference between passing and failing a technical interview. Moving into weeks 3 and 4, you will shift your focus to solving practical problems using arrays, strings, and hashing. For array traversal, you need to practice 3 specific techniques: 2 pointers, prefix sums, and sliding windows. You also need to learn how to use hash maps for frequency counting. As this diagram shows, characters from a string drop one by one into a hash map table, and the tally counters next to each unique character rapidly increment to track exactly how often they appear. Set a strict quota for yourself here. Solve 5 to 10 distinct problems for each of these subtopics before you allow yourself to move forward. Week 5 introduces recursion and backtracking. Simply put, recursion is a function that calls itself until it reaches a specific stopping point. To understand how this logic works, practice classic target problems, like calculating factorials, generating the Fibonacci sequence, and solving the n-queens puzzle. Be prepared. Recursion is a major failure point where many candidates quit. Pushing through with consistent repetition this week is the only way to make the abstract logic finally click into place. In week 6, the focus shifts to linked lists, stacks, and queues. Your goal here is to understand how they work internally, rather than just using them as built-in Python tools. Practice operations like insertion, deletion, and building a balanced parentheses checker. This visual demonstrates a stack operating on a last-in, first-out principle. The blocks drop into a vertical container, and the topmost block, the last one in, is the first one removed. Weeks 7 and 8 introduce trees and binary search trees. These are among the most frequently asked topics in any technical interview. The mandatory operations you must master include determining a tree's height, finding the lowest common ancestor, and executing traversals. You need to differentiate between the 3 main tree traversals: in order, pre-order, and post-order. In this binary tree structure, the nodes illuminate left, then root, then right, tracing the exact path of an in-order traversal. Mastering tree structures forces a necessary shift in your mindset. You move from processing data linearly to solving problems hierarchically. Week 9 targets heaps. You will implement min heaps, max heaps, and priority queues specifically to solve top K elements problems, like finding the K largest elements in a dataset. Weeks 10 and 11 cover graphs. This is an advanced topic that requires specialized traversal algorithms to navigate relationships between data points. You will need to contrast the 2 primary graph search methods.
Looking at this network of connected nodes, the left side illuminates in wide concentric rings to show breadth-first search. On the right, a single deep winding path illuminates to the bottom, demonstrating depth-first search. Week 12 covers dynamic programming. You will learn its two primary approaches: memoization for top-down processing and tabulation for bottom-up processing. Dynamic programming is the absolute toughest topic on the roadmap, expected to require high-effort concentration, acting as a secondary quit point for many learners. Once the 12-week theory phase is complete, you transition into ongoing daily coding practice. Progress strictly from easy problems to medium and finally to hard problems. Deeply analyzing your mistakes during this daily practice is what builds the pattern recognition required to conquer dynamic programming. Rote memorization will not work here. With that, you are now armed with a concrete 3-month battle plan. Let's review the complete map. This graphic details the entire chronological flow from week 1 through week 12, covering Python basics, time complexity, core data structures, advanced algorithms, and daily practice. Pause the video right now and take a screenshot of this roadmap graphic so you can keep it as your personal guide. Your final challenge is simple. Open up a code editor today, block out 1 hour, and immediately begin week 1. Talent helps, but structured consistency over the next 12 weeks is the only guaranteed metric for technical interview success.